Okay, welcome back. We're going to work with some polynomial division. And the question will be, when we try to divide the polynomials, do we get a remainder, or does the division come out evenly? Let's start with an example where we're going to compare and contrast long division and synthetic division. And each time we're going to find the quotient and a possible remainder when this third degree polynomial here is divided by this linear factor right here. So we have 2x cubed plus 5x squared minus 5x minus 2 divided by x minus 2. Our dividend in red is written under the division symbol, and our divisor, this linear polynomial here, x minus 2, I've written in green. And to do the division, we ask ourselves a question. We look at these leading terms and ask, what times x would give us 2x cubed? Well, we need a factor of 2, and we need a factor of x squared, and we're going to write 2x squared in the quadratic column. Then we distribute 2x squared times x, 2x squared times negative 2, and division is repeated subtraction, so we're going to subtract the result. Anything minus itself will be 0, and 5 take away negative 4x squared will be a total of 9x squared. And we bring down the next factor. We start over and ask ourselves, x times what would give us 9x squared down here. Well, that'll be 9x. We record the positive 9x in the linear column, and then we distribute again. 9x times x, and then 9x times negative 2. And this is where we have to just slow down just a little bit. Anything minus itself, yeah, that's 0. But negative 5 take away negative 18 will end up being positive 13x. And we bring down our last term. Okay, we can see that we're going to get a constant 13, because 13 times x will give us this first term. We also take 13 times negative 2, and the division is not going to come out even. When we subtract, we'll have negative 2 take away negative 26 for a positive 24. We have a remainder. Okay. So this number 24 is called our remainder. And the way we could also record our answer here, we write our division problem as a quotient. Remember our cubic original polynomial. Oops, and that'll be minus 5x minus 2. So the dividend divided by the divisor ends up being this quadratic quotient. Dividend divided by the divisor is this quotient, plus our remainder 24, which is written back over the original divisor. Okay, so we've answered our question. We wanted to find the quotient and the remainder when we divided. Here's our quotient, and 24 was our remainder. Right, so proceeding into minute 4, we're going to compare the long division method of finding a quotient to the synthetic division method, where we end up just organizing and writing down the coefficients of each polynomial. So that red dividend, we just write down the 2, the 5, the negative 5, and the negative 2. The cubic coefficient, the quadratic coefficient, the linear coefficient, and the constant. And the user knows to what power of x the coefficient is attached by which column it's in. And we do have to watch out. If there was what we call a missing term, like if there was no quadratic term, we would have recorded a 0 in that column. Now here's a key feature of synthetic division. Things are going to seem a little backwards. But if the factor, or this divisor here, was x minus 2, then in synthetic division, we just write down plus 2, or the positive 2. So if this were considered x minus a, this number here would just be a every time. I don't know if you've seen synthetic division before. You might want to pause the video here and try it yourself. But the person just brings down this leading coefficient and then takes the divisor 2 times what we brought down. 2 times 2 is 4, and we record that in the next column, and we add and get 9. Everything's going to seem kind of backwards in synthetic division. We take 2 times the 9, which is 18, put it in the next column, and then add 2 times 13 in the next column, and add, and that last number is the remainder. And we learn to decode down here. We divided by a linear factor, so that decreases the degree of the polynomial by 1. And we interpret this last line, starting here with a 13, that's a constant. 9 is the linear coefficient. 2 is the quadratic coefficient. So we have our same answer as before, 2x squared plus 9x plus 13. But we have to remember to put the remainder 24 back over the divisor x minus 2. Okay. And if you look back in the video, that's the same answer that we had before, quotient and remainder. Okay, so keep that 24 in mind. As I move to the next slide, we'll just finish off this video reminding the viewer of the remainder theorem. Okay, so there's a connection between evaluating a polynomial at a number a and the remainder when you do division by x minus a. So there's a connection between evaluating a function and finding a remainder. So if we start with an original polynomial, capital F, and we were to divide it by this factor x minus a, then the remainder from the division is given by f evaluated at a. So connecting that to the example we've just seen, we used 2 methods to do this division. The cubic divided by x minus 2, so a is 2, and when we did the division we got a remainder 24. So a was 2. Now if I took my original polynomial right here, took that original cubic polynomial f and evaluated at 2, I would need to substitute a 2 everywhere there's an x. 2 times 2 cubed plus 5 times 2 squared minus 5 times 2 minus 2. And doing a little arithmetic, I get 2 times 8, 5 times 4, negative 5 times 2, oops, and I still need to subtract 2, and it looks like I get 36 minus 12, or 24. The remainder theorem guaranteed that f of 2 is going to be 24. Thank you.